Hello, welcome to my easy statistics. Please like, share and subscribe the channel. Contact me for data analysis and training. You can contact me through email or WhatsApp. How to do weighted effect coding for categorical independent variables. Weighted effect coding is an improvement over unweighted effect coding, specifically designed to handle situation where we have unequal group size in our categorical data. For example, if you want to do regression analysis and find the impact of exercise on weight loss, here we have two variables. Weight loss is a dependent variable and exercise group is a categorical variable. And this categorical variable is having four categories: swimming, running, cycling and aerobics. And in each group we have different number of respondents in the data. Total we have 43 respondents. In this, swimming is a 10. Running 14 respondents, cycling 8 and aerobics 11 members. When we have equal number of respondents, like in each category, if we have equal number of participants, then we can do unweighted effect coding. But if we have unequal numbers, like swimming 10 members are there, running 14 members are there, cycling 8 and aerobics 11, in this case we need to do weighted effect coding. It means we are giving weightage to each group basing on the number. So in this case we need to do weighted effect coding. I repeat once again, when we have categories with different number of respondents, then we must do weighted effect coding. If we have equal number of respondents in each category, we must do unweighted effect coding. So in this case we are doing weighted effect coding. Now let us see here. Swimming, running, cycling and aerobics, there are four categories. So when you do weighted effect coding, we are going to get three variables, that is W1, W2 and W3, that is number of categories minus 1. Here we have 4 minus 1 is 3. So we need to create weighted effect codings. 3 codings must be done. So in this case I am doing three codings, W1, W2 and W3. And before we start, we need to select one of the category as a base group. It is up to our choice of which category you are going to select. In this case I am selecting running as a base group. When you select running as a base group, you must follow this small formula, that is N1. For example, you see W1. Here we have N1 divided by N2. What is N1? N1 is a swimming, number of respondents, we have 10. And running, N2 is a running, we have 14 members. So 10 divided by 14. So this formula we must use for running. For running is taken as a base. For base, for each coding we must take the particular variables. W1 is a weighted effect coding for swimming. W2 is a weighted effect code for cycling. W3 is a weighted effect code for aerobics. So when you say swimming, W1 is for swimming. How many number of respondents we have in swimming? 10. So we must select 10 divided by 14 for W1. For W2 we must select cycling. Cycling is 8. 8 divided by again 14. And W3 is for aerobics. Aerobics 11. So 11 divided by 14. So this is important to understand when we are doing effect coding. You can see here I have did the same thing. We have taken effect coding for swimming, running, cycling and aerobics. These values we got. Now what we'll do, we'll go to SPSS and we do this coding and do the analysis further. This is SPSS software. We have weight loss and exercise. Exercise, you can see this is one is for swimming. Okay, for swimming we got 1 we have given for W1, and for running we have made the same thing, minus 10 by 14 we got 0.714. This is for the next one, cycling, and this is for aerobics. So the coding is done in this case. Total 43 respondents. Now let us do the analysis. Analyze, regression. In regression, linear. Select weight loss as a dependent variable and select swimming, cycling, aerobics as independent variables. Now click OK. Now we got the analysis. We first interpret the model summary as usual. In ANOVA, we got the significant value as 0.000, which is less than 0.05. Important thing is to interpret the coefficients values of unstandardized coefficient values for the categories swimming, cycling, aerobics. This is the coefficient value which I have copied from the SPSS software. You can see the constant is 8.025. The constant coefficient of 8.025 represents the estimated weight loss in kilograms when someone engages in the baseline activity, that is running in this case, while holding other variables constant. The p-value is less than 0.05, so it is significant. Now we'll see how we got this value 8.025. Now this is the weighted mean for 4 exercise groups. Already we have seen swimming n is equal to 10 and the mean value for swimming group is 6.070 into 10, that is nothing but 60.7. In my earlier videos, I have shown you how to calculate the mean weights for each category: swimming, running, cycling and aerobics. You can follow that one. If not, I'll show you once again how to get the mean weights for each categories. For getting mean weights, you must first go for data, split file. In terms of organize output by group, take exercises. Now exercise categories wise we are going to get the output. Click OK. Now go to analyze. In analyze at descriptives, in descriptives again descriptive. Now we want to go in terms of weight loss. Now click OK. Now you can see swimming we got mean is 6.070, running mean is 9.5929 and for cycling it is 9.7375 and for aerobics the mean value for this category is 6.5636. Now the same thing we are doing. For running we got n is equal to 10. The mean value for swimming is 6.070 into 10, 60.7. Running n is equal to 14. 9.593 is a mean value for running category. Into 14 we got this value 134.302. For cycling n is equal to 8. The mean value for cycling is 9.738 into 8, that is 77.904. For aerobics n is equal to 11. The mean value is 6.563 into 11, 72.193. So when you do weighted mean, you add all these values divided by 43. What is 43? If we add 10 plus 14 plus 8 plus 11, this is the total number of respondents are 43. So 345.099 divided by 43 is 8.026. So this is a value which we got the constant here. 8.025 we got it. When you do calculation wise, we got 8.026. So this is how we got the mean weight. So this is the running value. Next we will see for swimming unweighted coefficients. Here we got minus 1.955. The coefficient of minus 1.955 for swimming suggests that compared to running, individuals who engage in swimming tend to experience a decrease in weight loss by approximately 1.955 kilograms. And this is significant. The significant value is 0.004, which is less than 0.05. So this is significant. So person who is swimming is having weight loss less by 1.955 kilograms compared to running. How we got this value calculation wise? we can see this one. Weight loss for swimming, running, cycling, aerobics I have shown here. And weighted group mean for 4 exercises we have shown already calculated 8.026. So the difference between swimming and weighted group mean is minus 1.955. That is 6.070 minus 8.026 is equal to how much? We are going to get minus 1.955. That is nothing but the unweighted coefficient for swimming. So this is how we got the value. Now we will do for cycling. Cycling, the coefficient of 1.7212 for cycling indicates that compared to running, individuals who engage in cycling tend to experience an increase in weight loss by approximately 1.712 kilograms. And this is significant because the significant value in this case is 0.024, which is less than 0.05. So this is significant. Now let us see how we got this 1.712. Same thing. Here, this is the difference between cycling and weighted group mean. Cycling, what is the value we got here? 9.593 minus weighted group mean for 4 exercises, how much? 8.026. If we take the difference between these two, cycling and exercise, we are going to get 1.712. Now next we are going to see for aerobics. The coefficient of minus 1.462 for aerobics suggests that compared to running, individuals who engage in aerobics tend to experience a decrease in weight loss by approximately 1.462 kilograms. It is a person who is doing aerobics has weight loss less by 1.462 kilograms compared to running. How we got this coefficient value? Same thing. This is the difference between aerobics, mean of aerobics, and weighted group mean of the 4 exercises. You can see aerobics is 6.563 and minus the 4 weighted minus weighted group mean of the 4 exercise 8.026. If we take the difference, we are going to get minus 1.462. So this is the coefficient, unstandardized coefficient for aerobics. So this is how we are going to do the analysis for weighted effect coding.